guys, we're back, and in this week's episode we're going to talk about this whole fabricated wing we made here, all the brackets, and some of the other little goodies that go along with it. So you can see here, it's all the sheet metal wing with all the rivets, 1.25 inch on center, and then it's still not done yet, it's still a work in progress, but I wanted to give you an update. It still has to get all the rivets down this way to attach to all the diaphragms inside. You can see the end plates here. It has all bolts around the outside and across the bottom. And they're all gonna have button head Allens from the outside of the wing, just because I don't like the new style where it just has like 2 bolts in it and the adjustable end plates. I wanted them a little more fixed, like an old car where they were all riveted together, just to go with the theme of the truck, which I should probably get to since I never actually talked about the theme of the truck, or at least where in my mind it's headed. The main theme is like an old 70s, 80s like Can-Am car. So all the riveted sheet metal, the big V12, which is the reason I wanted it. I want to have like probably 12 independent throttle bodies with the big horns on it. The whole truck, as of now, is going to be orange and blue with all old like golf racing decals on it. Just a, you know, my take on an old race car, or race truck, I guess it would be. But yeah, so now we're going to get into how we actually made this wing from start to end. Well, start to where we are. So here's our most recent design of the wing. You can see where we put all these extra cuts for the reliefs for when it gets bent. And then you can see I added all the rivet holes. They're a little under an 1/8 inch, so I have to drill them out, but at least they're all centered exactly where I need them for a pilot. This will get a bar going across here, and then this will be like a diaphragm to keep the wing from racking before it gets skinned. These holes here are actually a pilot bolt, but you'll see more of that when we go to bend it. So here I'm going to show you guys it cutting it out on the plasma, and then I'll show you some of our earlier tries that didn't exactly work out. So there you go. There's yet another one cut out. But now I'll show you some of our earlier tries. Here is our very first attempt. We didn't really know what to expect, so we just wanted it a baseline as to where everything would and wouldn't bend. Then we tried some bigger slots. As you can see, it still just didn't have enough relief for the metal to go to. So then Matt decided to try these super close slots that are only a 1/16 wide or so. Worked out nice. We just saw, I can get it to focus, right there, some overlapping in it. So we just went back and cut a little bit more out until this one didn't work either, but we just kept fine-tuning it until they just missed each other. And then here's the mold that I was talking about. See, so this is just wood, and it's actually ground on a slight taper underneath by 5 degrees, so that when the mold comes down and presses on it, it actually can curve underneath, so that when it springs back, it's nice and straight, so that it's exactly what we need. But there's the pilot holes that I was talking about, so it centers itself exactly where we need it every time. Just line the holes up, put your pins in, and then you can see how it lines up all the way around underneath, right to where it needs to be. You put it in the box. Same thing, make sure it's nice and lubed up, or else it just tries to tear the rubber. Okay, here you can see the piece formed all the way around pretty nicely. For some reason these back three don't, but you just hit them with a little body hammer and it finishes them all. So now you can see the nice contours and gives me a nice area to put all my rivets in. And I have all my holes where there's other ribs that I made rivet into. So the next piece that I designed is these cross braces here that actually connect over here to those two profiled pieces that I made earlier. There's the rivet holes. I made a couple try-on errors just to find the locations up and down of these holes so that when I put it into the brake and I bend it, the heights all line up to match and everything. So now I'll cut one out and I'll show you the fit up. So here's the piece all cut out. You can see the holes. They're a little undersized, so I have to drill them out for the rivets. Here's all the ones I have cut so far. But here's the pieces when they're stamped and done. You can see the holes on each end, how they're offset. And then these just go on to like that. So you can see I got the holes line up in there and they're offset nice and smooth across the top and bottom. So here are the molds that I made for the front and back pieces of the wings. I have them labeled top and then with the arrows down. And what that means is this is the top and these holes here favor the bottom just slightly with it where the arrow goes. Now you can see they line up and you put these bolts in and that's what holds it exactly where it needs to go. And then same for the rear ones. These just aren't as complicated. Just put them in. And then you can see how I have them mitered in different angles to form the wing correctly. And you take them, set them in here, spray them with WD-40. Put the lid to the box, very heavy. And then press it down. And there's your pieces all formed, bent to the correct angles, the ears bent down. And same for that one. You can see the fit up's pretty tight all the way around the wood. So here's the wing brackets for mounting the wing. I drew it in AutoCAD. So here's the profile of the wing so it fits in nice and close, and then it comes down to hold each tab, the front and the back. So to cut it out of aluminum, I put 2 Tech screws in it, and then I cut them all flush from the back, and now I can take it to the vertical bandsaw and just cut along the edge, and then I can take it to the grinder and just grind it to match this profile here so it comes out identical to the other side. So we're ready to bolt the two sections of the wing together here. I got that tab all done, made up. See, I've radiused all the corners nice. And it has the profile of the wing here. I put these two bolt holes in it here that actually line up with the holes that I was using for the press when I formed the pieces. So this will bolt in exactly where those holes are already formed in the pieces. So these just go.
So in order to get this tight radius for the front of the wing, we're going to have to make our own die for the brake. So to do that, we're going to use a piece of 3/8 round bar and a piece of 3x1/2 flat bar. Stitch weld them together, and then we'll just use a regular bottom die for a roll, and hopefully that gives us the radius we need. Am I close up? So now we're bending test pieces to make the wrapper that's actually going to wrap around these ribs that Dylan made. So basically we just took a flat piece of aluminum and started bending it. You know, we kind of guessed on the spaces and how hard, and messed with it, kept changing it, changed different depths of stroke on the brake, different distances apart on the bends.
And there's our pile of fuck ups so far that haven't worked.
Yeah, there's a lot of those. So we actually got it really close. You can see how well that fits. And then give you a better view. Like that. We are going to move this bend a little closer.
So we got all the bends done. Here you can see them all the way around. So after the wing was designed, we started going into wing brackets. It was a pretty complicated drawing to make for me and Matt, partly because I want everything mounted in double shear because the bolts are going to be loose since the wing's going to move and everything. We can't have everything tight, so I wanted everything supported on both sides so nothing can lean or fall or anything. So here's the wing bracket design that we came up with. You can see up here, this top section is missing because that'll weld to either side and clamp this so that the wing can slide into a slot and be supported on both sides. And then down here, this hole is going to hold.
These actuators are what's actually going to make the wing active aero. So these will bolt down here. We're going to put a slot in the bottom right through the center of the mount, just like we did on the top. That way it's in double shear, like Dylan said. The bottom mount is going to straddle our 3/8 aluminum plate, and the top is going to bolt to the back side of the wing.
And then to design the wing brackets themselves, what we did was, you saw the 1/4-inch plate that we cut out. I drilled holes in it where holes weren't going to matter if they were there. And I actually self-drilled holes through with Tech screws here, ran them through the aluminum plate, and then I cut the backs of the bolts off flush so it was nice and smooth. And then I used a router bit like this with on a router table, and I used that as just a guide to make it perfectly flush across the top, and that gave the bearing something to ride on, cut the pieces out. It was the easiest way. All we did was, on AutoCAD, we took this and made everything a 3/16 bigger on either side in case the kerf went off or anything. So that just was the meat that we removed off around the outside. And then you can see we did the same mold style setup here with these little ones and these ones. We bolted it together with 2 bolts and just ran the router around it again.
So here's what that looks like assembled. Obviously it's not welded yet, but the 2 tabs will overlap the bottom bracket about a 1/2 inch. You know, we'll plug weld that hole, blend it smooth. But then the wing will sit right down in this slot and pivot.
And now we're getting ready. We're gonna use just a round over bit on the router and round over all the corners just so it's not as sharp looking when we're all done. And then after that, we're gonna throw the welds on and start designing the brackets that hold the bottom of the wing to the truck. So that'll be a whole nother section because these actually intersect at a 15-degree angle through the pipes. So it's gonna have a very, very long arc of a piece that we're gonna have to design and draw on AutoCAD for you guys to see how we actually mount them to the truck.
All right, let me give you guys a little rundown on this router table, quote unquote. What we got here is a regular rigid router with the base plate taken off of it and a piece of 1/4-inch aluminum with counterbore holes in its place. Works well, good enough for what we're doing. All right, so now Dylan got the edges all routed with a 1/8 radius on that router table we showed you. Just transforms the whole piece into going from like a piece of aluminum to an actual part. Even did the 1/4 plate pieces at the top. You can see how good they look. So now we bolted those together with 3/8 of an inch of washers in between them, and we overlapped it a 1/2 inch onto the main bracket. So now all that's left is to weld her up. So we used Fusion to get this profile. And what this is a mock-up bracket that will sit on this upper roll cage bar and we had to get this fancy profile on it so that it was parallel to the truck while crossing over top of the bar. So now we basically just have this piece as a reference to draw the brackets that will mount the mounts. So I held this up to the truck and marked out where they land so that you can see my reference marks on it. I have the same thing on this side with another piece. So now I'm going to take measurements of like this distance here, same thing on this side. That actually already lines up pretty well, but this one you could see it sticks out past. So I'll trim all those up, make some longer, and we'll burn out another set and probably another set until we have some good looking brackets.
Hi everyone, my name is Dylan Perry. I'm going to be kind of designing the actuator mechanism and the programming for the wing. So we're using these 12-volt actuators hooked up to an Arduino Nano. It's going to have an accelerometer sensor and a GPS sensor. The accelerometer is just a simple one-axis that detects how fast or how slow you're going and like braking and everything. And so the Nano will basically detect how the acceleration, deceleration, and the GPS movement, just to kind of get the wing in the right place at the right time.
So the reason we want both sensors is under acceleration, you're going to want the wing to go to 0 to create the least amount of drag so you can accelerate as hard as you can. But up to about 60, I want the wing to sit at about a 15-degree angle of attack just so it has the most amount of downforce. And then by about 120 miles an hour, I want the wing to drop down to about a 5-degree angle of attack, just so I'm not creating a huge amount of drag or way too much downforce. So the speed sensor is going to create a linear drop of the wing under those speeds as you accelerate. But I want to use the accelerometer for anything above like a 0.5 G acceleration, have the wing go to 0, and then anything over 0.5 G deceleration, as if you're on the brakes, I'm going to actually try and make the wing as an air brake where it tries to stand up as much as it can to slow the car down. So that's why I feel like I need both sensors to do exactly how I want it to work.
Yep. And we're actually in the midst of determining whether or not we need a homing switch kind of in the middle, just to kind of give the actuators a point of like calibration and resyncing, just to make sure they're all in line. And then the one-axis accelerometer, it is actually variable sensitivity. It can go from plus or minus 1.5 Gs sensitivity to plus or minus 6.5 Gs, depending on how much we need. Well, we're not going to need that much, so we're probably going to just keep it at plus or minus 1.5 Gs.
I really hope I'm not taking any turns above 1.5. That might get a little scary.
Might pass out.
Yeah.
All right, if you're still awake, thanks for watching. Don't forget to like and subscribe.
And if you have any questions, comments, or constructive criticisms, please let us know in the comments. Thanks.